We're going to look at graphing lines. Remember, the standard form is ax plus by is equal to c. This is a linear equation in two variables, and that's the standard form. To graph a line, a graph of an equation is an illustration of the set of points whose order paired are solution to the equation. How many points you can find on this line? There are infinite points, right? If I let x be equal to -1 and then find the corresponding value, I get y is equal to 4. If I let x be equal to 1, find the corresponding number, y is equal to 1. So there are infinitely many points we can find when I have an equation. I can let x equal to any number I want and find the corresponding number for y, right? How many points do I need to graph that line? Only 2, right? Now, preferably, you will look for x and y intercepts when you want to graph a line. Because if I find the x-intercept here and y-intercept here, you would be more accurate as where the position of this line is. So if it's really up to you, look for the x. You let x equal to 0, solve for y equal to 0, solve for x. Sometimes they actually ask you to find the x and y intercept. So once again, if I let x equal to 0, solve for y, that's y-intercept because you're solving for y, right? Similarly, if I let y equal to 0 and solve for x, that would be your x-intercept. That would be this point right there. Now we know what x and y intercepts are. So to finding intercepts, if you let y equal to 0 and solve for x, that's your x-intercept. If you let x equal to 0, solve for y, that's your y-intercept. Okay, finding intercept. Find the x and y-intercept for this equation. Notice that this is standard form, right? It's 2x minus 1y, or just minus y equal to 4. So you let y equal to 0, solve for x, that is your x-intercept. You let x equal to 0, solve for y, and that's your y-intercept. Simple as that. That's how you find x and y-intercepts. Once you find the x and y-intercept, if you locate those 2 points and connect them together, that would be the graph of your line. You put a little arrow here, that means that line goes all the way to infinity from both ways. And as you see, if we find another point, if you let x equal to 1 and solve for y, you see that other point would lie right on the same line. So let's take a look at another example. Graph 3x minus y is equal to 0. We're going to let y be equal to 0, solve for x. 3x equal to 0, divide both sides by 3. The coefficient is 3, so x equal to 0. Now, this time, your graph is going to pass through the origin. So it means both x and y intercept could be 0, 0, right? So that would be a case where your line passes through the origin, then they have the same. So in order to graph this, I need another point. Graph 3x minus y equal to 0. If I let x equal to 1 here, solve for y, you see y equal to 3. Here it is. I have another point. I can connect them together, and that would be my graph. This would be an example where my graph passes through the origin.